Start section 3.2, polynomial function with higher degree. So polynomial function if the graph of the polynomial function, just write down here continuous. Polynomial function is continuous if the graph of the polynomial function has no break, hole, or gaps. Write down polynomial function is continuous if the graph of the polynomial function has no break, hole, or gaps. Here, the leading coefficient test. This is like another note. A leading coefficient test is used to test the left hand or the right hand of the graph. So it's like leading coefficient test. We're always going to use this test to test the end behavior of the polynomial function. So like the left side or the right side of the polynomial, if it's going up or down. So for example, it's not example, here is the rule. Here is the standard form for the polynomial function. This is the leading coefficient. Leading coefficient test is going to be here is the highest exponent. So we're gonna work on this one. When n is odd, that means the exponent is odd number, 3, 5, 7, and a, which is the coefficient, is greater than 0. That means the end behavior, this side, the right side is up, the left side is down. If a is less than 0, that means negative number, so the left side is up and the right side is down. Let's do a simple example here with numbers. So if we have this polynomial function, f of x equal 3, let's do x to the power 5 minus 5x plus 6. This is the polynomial function. I need to check the coefficient, the leading coefficient test. So here is the highest exponent, which is x to the power 5. This is the leading coefficient, which is 3. That means a equal 3. Now I'm going to check. This is n equal odd number. So n is odd. That means n is odd. A is equal to 3, which is greater than 0. So I'm going to keep in mind, when I'm going to graph the function, my function is going to be this side is up and this side is down. So I'm just going to keep in my mind, I'm not going to care about what's going to happen now in the middle. Like this, the function, but the main thing, this side is up, this side is down. The same example, if we have f of x equal negative 3, x to the power 5 minus 5x plus 6. Now it's different because now the leading coefficient is a equal negative 3, negative number, and n equal odd. That means I'm going to work on this one, this option. A is negative number. That means when I'm going to graph the polynomial function, this side is going to be up and this side is going to be down. Again, I'm not going to care about here in the middle because I'm going to figure out with the next step. Okay, so that's meaning the end behavior, or here they call it the left hand or the right hand of the graph. If you want to write down these two examples. So we have it's like here's 4 examples. A is positive number and odd. A is negative number and odd. A is positive number and n is even. A is negative number, n is even. So that's how it's going to be. And again, we're just checking the end behavior of the graph. We're not going to care about the function here, how it looks like. The main thing we're going to care about the left hand of the graph and the right hand of the graph. So this is the first part. Let's keep going. real zeros. So now in this one, for the polynomial function, we're not gonna say solution anymore. They're gonna tell you real zero. So let f of x be a polynomial function. The function f has at most n real zeros. That's mean on the same time n real solution. So we're not gonna say solution anymore, we're just gonna say zeros. The graph of f has at most n minus 1 term points. N minus 1 term points. So keep these two notes in your mind. Now we're gonna say zeros. How many term points for the graph? N minus 1. So if we go back to these examples, simple examples, n here is 4. That's mean term point is going to be 4 minus 1 is going to be 3. That's mean we have 3 turning points. So the graph, this side is down, this side is down. We have 1, 2, 3 turning points. Maybe look like this. So I'm going to keep in my mind, I have 3 turning points. That means the graph is turning 3 times. This is just an example about the turning points. Let's go to the next page. Now let f be a function and a be a real number. Then these are the important stuff. 1 to 4. First of all, a equals 0. Again, it's a solution because when you say x equals 5, x equals 6, that's going to be the solution. But now we're going to say x equals 0, x equals a is a 0 of the function. So again, when you hear a 0, it's the same thing, it's a solution. A equal a, x equal a is a 0 of the function of f. X equal a, which is the same thing, is a solution of the polynomial. F of x equals 0. It's a 0 for the function f. It's a solution for the polynomial. X minus a, when you factor the polynomial and you get 3 parentheses or 2 parentheses, this parentheses is called factor of the polynomial. A, which is the number here with the 0, is going to be the x-intercept. The x-intercept. So these 4 notes are really important. And that's what they're going to ask you with the, I think, 7 questions in the beginning. So again, when we see the when you factor the polynomial, let's do a simple example. Like if you have x squared, let's say minus 5x plus 6. This is a polynomial. F of x equal. So then when we factor this one, we're going to say f of x equal. We're going to open 2 parentheses. 1x here, 1x here. I can use a 3 and 2 minus minus. So I just factor the polynomial. This parentheses and this one is called, these are 2 zeros of the polynomial f of x. So now this one is a zeros for the polynomial f of x. X minus 2, x minus 3. These are 2 zeros or 2 factors because x minus a, 2 factors for the polynomial f of x. And when you solve this one, you're going to say x minus 2 equals 0, x minus 3 equals 0. You're going to add 2. So x is going to be equal to 2. You're going to add a 3 here on this side. So x is going to be equal 3. Now, this one is called solution or it's called 0. You can call this is x equal 3 is 0 of f of x. The same thing, this is called 0 of f of x. You can write down the x-intercept The x-intercept is going to be the number. This is A with the 0. That means AX here is a 3 with the 0. This is the first x-intercept. And this is the second x-intercept. These are too important to grab the polynomial function. Repeated 0 when you have parentheses with exponents. Parentheses with exponent. This is called repeated 0. So let's check the rule for this one. So a factor, you see these parentheses with exponents. And k is greater than 0, that means positive number, is repeated 0 with k multiplicity. So we're going to say this is a repeated 0 with k multiplicity. For example, I'm just going to write down simple example here. If you have f of x equal like x minus 3 to the power 4. So this is the factor you see here with the k multiplicity. That means this factor is repeated 4 times. This factor is repeated 4 times. That means you can write down this parentheses 4 times. So this is called k multiplicity. So we have 2 notes on the multiplicity. When k is odd, like for this example, f of x equal x minus 3 to the power 5. These are 2 examples. When k is odd, like this example, the graph cross x-axis at x equal a. The graph is going to cross x-axis. X-axis at this point here. The graph is going to cross x-axis. If when k is even, the graph touch x-axis at the point here, like this example. So with the first one, the graph is gonna, with the first one, at this point, when you graph it, it says when k is odd number, let's say x equal to 3, here's x equal to 3. So when you graph it, the graph is gonna cross at this point. This is x equal to 3, like the graph is gonna be cross the x-axis at this point when x equal to 3. Then the second one, when k is even, like with the first example here, the graph is going to touch 1, 2, 3. This is x equal to 3. The graph is going to touch the x-axis like this. It's not going to cross. It's just going to touch the x-axis and move back, or from the bottom. It doesn't matter. Like it's going to be here or like this. The same thing here cross or here cross. The main thing is to cross at this point, and when k is odd, even, is going to touch the graph like this. Okay, this is for the first one and the second one. This is also like important. Before you start factoring the polynomial, always we have to write down the polynomial function in descending order. That's mean from the highest exponents to the lowest exponents before you start graphing the polynomial. So a polynomial function written in a standard form when its terms are in descending order of exponents from left to the right, always from the left to the right, from the highest exponent to the lowest one. Here's just a theorem, intermediate value theorem. This is important. If you take another math class, you're gonna go using advanced for this theorem. If you take in pre-cal or cal 1. So let a and b be a real numbers such that a less than b. Just a real numbers, a less than b. That means 0 and 5. 0 and 7, 1 and 7. Two numbers, two real numbers, but A always less than from B. If f is a polynomial function such that f to the A, that's mean the y coordinate for this point, not equal to f to the B, not equal to the y coordinate for the B, then in the interval AB takes on every value between f of A and f of B. So every value between f of A and f of B is going to be between these two intervals. This is just a simple explanation about the intermediate value theorem. Now, how to graph polynomial in general, like if they ask you someone graph this polynomial, we need to, the first thing, find the x-intercept, find the y-intercept, test the left and right hand of the graph. We're going to test the left and the right hand of the graph. Then sometimes we're going to choose extra points to graph the polynomial function. I'm going to give you the steps. So let's graph example 9. We have f of x equal negative 2x squared minus 7x. So that's what they ask you. Let's find the first one, find the x-intercept. How are we going to find the x-intercept? We're going to let y equals 0, or f of x equals 0. That means f of x equals 0. So this is step 1, x-intercept. We're going to let f of x equals 0. Okay, so 0 is going to be equal negative 2x squared minus 7x. Then now I'm going to work on this one because I need to find the x-intercept, which is on the same time, it's the factor of the polynomial. So how I'm going to factor this side? To factor this side, we're going to say 0. If you want to, you can factor the polynomial on the beginning. It's going to be easier for you. Let's do these steps. Before I'm starting finding the x-intercept, I'm going to say, okay, let's find the zeros. That means I need to factor the polynomial. So I'm going to say f of x equal, the only thing I can factor it here is the negative sign and the x as a GCF. So I'm going to say negative x equal, and the left is going to be 2x minus 7. Now, I have two factors here. You can write down this in parentheses. So this means this is a factor, and this is also a factor for the polynomial, f of x. Now, step 1, find the x-intercept. Which is mean, let f of x equals 0. So I'm going to put 0 here. That means 0 is going to be equal negative x and 2x minus 7. Then next step, I need to solve this one by using the zero factor theorem. 2 parts equals 0. That means 0 is going to be equal negative x, and 0 is going to be equal to x minus 7. 0 equal negative x, that means x equals 0. So the first x-intercept, x is 0, y is 0. On the other side, I'm just going to add 7. This is cancelled. So 7 is going to be equal to 2x. Divide both sides by 2. So x is going to be equal 7 over 2. So the second x-intercept is 7 over 2 and 0. 7 over 2, if you divide 7 by 2, is going to be 3.7. 7 divided by 2, 3.5. So you can, when you graph it, you're going to say 3.5, it's easier to graph with the 0. Now let's check. I just found the x-intercept. The second one, we need to find the y-intercept. So we're going to let x equal 0. I'm going to put here, this is the first point, and here is the second point. Now find the y-intercept. We're going to let x equals 0. So I'm going to plug in 0 here, here, and here. So that's mean f of the x, which is the y, f of the 0 equal negative 0. Yes, go ahead.
Someone has a comment or something in the chat.
Oh, okay.
Wouldn't it?
So I took the negative sign. This is positive. This is positive. This is positive. We're going to minus x, minus x, minus x, minus x. So it's going to be negative number. Perfect. I need my coffee. So now this one, we're going to plug in the 0 here. This is negative. That means it's going to be negative 0. 2 times 0 plus 7. And then it's going to be, this is 0 times anything here. The result is going to be, because this is 0 plus 7 is going to be 7. 7 times 0 is going to be 0. That means y-intercept, the point 0, 0. The third step, we're going to find the end behavior, or you can say the left-right hand. It's the same thing, the end behavior of the graph from both sides. So here is the polynomial function. I'm going to go back to the general form, not the one when I factored. The general, the standard form of the polynomial function. And I'm going to check. 2, that means n equal 2, which is even number. Then the next one, a, which is the leading coefficient, is negative 2, which is less than 0. That means both sides of the graph is going down. So let's check. By just locating the third step, I already know both sides of the graph is going down. That means I can't choose this one because this is both sides going up. I can't choose this one because this is also both sides going up. My graph is both sides going down. So it could be this one, could be this one. Okay, so let's check the other options. The x-intercept and the y-intercept. Here is the x-intercept, which is 0, 0. So this is x-intercept 0, 0. This is also x-intercept 0, 0. So both graph is right. We can choose both graph. But check here. We have another x-intercept, which is this point, negative 3, 5. So here is 1, 2, 3, and 0.5. This is the second x-intercept. How many x-intercept do we have here? We have 3 x-intercepts. That's why I can't choose this graph. So I'm going to choose this one. 2 x-intercept. Y-intercept is also 0, 0, which is here. And both sides is going down. So this is the right option. So I'm going ahead and choose this one. Okay, so we're just using these steps. Factor the polynomial, find x-intercept, find y-intercept, and find the end behavior to graph the polynomial function. So example 11, they said f of x equal x to the power 4 plus 2x cubed. x to the power 4 plus 2x cubed. So I'm going to do exactly the same thing. First of all, I'm going to factor the polynomial. So I'm going to say f of x is going to be equal. How are we going to factor this one? Always going to use the same step one, find the GCF. The GCF is x cubed. Then the left is going to be x plus 2. I'm done. This is the first step. We're going to factor the polynomial. Then number one, x-intercept. We're going to let f of x, which is the y, equals 0. That means this side equals 0. So I'm going to say 0 equal x cubed, x plus 2. How are we going to solve this one? I'm going to say 0 equal x cubed. And here I'm going to say 0 equal x plus 2. Check the cubic root for both sides. That means x equals 0. On the other side, which is going to say minus 2, minus 2. So x is going to be equal negative 2. That means I have two x-intercept, which is 0, 0, and negative 2, 0. I'm done from step 1. I found the x-intercept, which is the point 0, 0, and negative 2, 0. Step 2, find the y-intercept. We're going to let x equals 0. That means plug in 0 here. That means f to the 0, which is the y-intercept, equals 0 cubed, 0 plus 2. 0 plus 2 is going to be 2 times 0 is going to be 0. That means the y-intercept is going to be the point, x is 0, y is 0. I'm done from this one. Step 3, we're going to find the end behavior, which is the right and left behavior. The n equal 4, which is even number. A equal the leading coefficient, A equal, here's the leading coefficient. No, we're going to go to the standard form. Here, the leading coefficient is 1, not the factored form, the standard form. The leading coefficient is 1, which is greater than 0. That means the end behavior for the graph on both sides is going up. So by just locating the third step, I'm going to know my graph, not this one, and not this one, because both sides going up. Maybe this one, this is both sides up, maybe this one. Let's check the other points. The x-intercept. The x-intercept here is 0, 0, which is this one. And for this graph, also this one. The second one is negative 2, 0. So here is negative 1, here is negative 2. This here is 1, 2. It's 2, 0. That means I can't choose this graph. Okay, so this is the right graph, but you're gonna ask, y-intercept is 0, 0, the same point. So this is the right option. But how are we gonna use the extra points? Here's the thing. Now, if you graph these points without looking, because we already have the graph here, and we just matching the points, but what about if you wanna graph it by yourself? So you're gonna say, put down the x-intercept, 0, 0, 1, 2. This is the second one. The y-intercept, which is the point, 0, 0. My graph is going up from both sides. It's going up here and it's going up here. You see, from these 2 points, the graph going up. But what about the graph, how it look like between these 2 points? I told you, we already know the graph look like this. So we just matching the points. But if you want to graph it, you have to do these steps. So here's the graph from this side. So now, x-intercept, the second one here. Y-intercept here, the graph is going up from both sides. So here is the first x-intercept, the graph is going up. The second one, the graph is going up. But what about between these 2 points? The graph like this or the graph like this? So we have to know, we have to check that. You're not gonna just assume the graph is going down. Maybe it's going up a little bit and down. So we have to check. How are we gonna check? By doing extra point. The extra point. So I'm gonna choose point between these 2. This is the easiest one, -1. X, Y. I'm gonna choose x equal -1. Plug in -1 here. It's going to be -1 to the power 4 plus 2 times -1 cubed. That means it's going to be equal, let's do it down. -1 to the power 4 is going to be 1. -1 cubed is going to be -1 times 2, -2. And it's going to be -1. So when you choose the point -1, the y is -1. That means we have this point. Let's graph this point. Here's -1, and here is the y -1, so it's going to be here. That means the graph is gonna go down here and then going back up again. So in fact, because we have it cubed, the graph is going to be like this little bit. And going back again to this point. So that's the way to graph it. That's the way to graph it, by using these steps. The extra point to locate the graph between these 2 x-intercepts is going to be up or down. Check here. At this point, the x cubed, and I already know the graph of x cubed like this. One side is up and one side is down. So that's why it looks like this. But the graph is stepped here and go back again up. So that's how we're gonna graph it. But again, if you have the graph, you just have to match the points and check the end behavior of the graph, which is the left and the right side, and you're gonna choose which one is the right one. So let's go to example 12. We're gonna do exactly the same steps to find which one is going to be the right one. Now you see, it's gonna be a little bit harder, but we're gonna do exactly the same thing. So 12, we have alpha fill x equal 1/5 x to the power 5 and minus 2x cubed plus 7/5 x. You're gonna say, oh, this is a fraction. I know you hate a fraction, but let's check how we're gonna work on it. The first step, what I'm going to do, I'm gonna factor this one. The only thing you're gonna factor this one is the x. So let's factor the x out, but you can simplify this one. If you multiply it by 5, it's going to be easier. But let's first just factor the x out and check how it's going to be. Because the common is x, so I'm gonna say x out. And here is going to be or we can factor here is 2, which is 5 over 10, 10 over 5. Then we're going to factor out the 1 over 5. So that's what I'm going to do. I'm going to show you this step first. Then I'm going to say this is 1 over 5 x to the power 4 minus 2 x squared plus 7 over 5. If you want to keep it like this and keep working on it, if you want to delete the fraction, just look like you're multiplying everything here by 5. Everything here by 5. Or if you want to check the 1 over 5 as an out, as a common, so here is going to be f of x equal, it's up to you which option you're going to use. Let's keep it like this and work on it, because this one, if it's 10 and this is 1 and this is 7, we can't use the quadratic formula. So we have to use the quadratic formula on the rest. Okay, let's factor out the 1/5 out. That's been 1 over 5, and here is the x. So it's going to be x to the power 4 minus 10x squared plus 7. So now I'm done from factoring out everything. Stop the recording. So again, what we did here, we took 10, negative 2 is 10 over 5. I'm going to take 1 over 5 as a common. The left here is negative 10, and here is the leftover from everything. To find the x-intercept, let f of x equal 0. This side is going to be equal 0, so x is going to be 0. This is the first point. If you look to the second point, we can't factor this one. We have to use a quadratic formula. So let's use the quadratic formula. Zero equal, and keep going. Let's check if we multiply by 5. It's going to be easier. So let's keep going. Now, let's check that. How is going to be here? So you see, what I'm going to do, plug in everything here, the square root of parentheses negative 10 squared minus 4 times 1 times 7 is going to be, we're not going to work with this one, but it's okay, 8.48. Let's do it without the parentheses because I need a number. Negative 10 squared minus 4 times 1 times 7. Okay, 72. I'm going to keep 72 under the root. Then the next step, I'm going to convert it. So this is going to be 10 plus or minus square root of 72 over 2. That means it's going to be 10 plus or minus 8.4849. Let's do 5. 3 decimals, divide by 2. I'm going to use the decimals because it's easier for me to graph it with the decimals. I can't graph it with the fraction. So I have 2 points from here. X is going to be equal 10 plus 8.485 over 2. And the second one, x is going to equal 10 minus 8.485 divided by 2. So if you add this number with the 10, it's going to be 18, and divided by 2 is going to be 9.24. That's mean 9.24. Okay, Now it's easier for me to graph 9 point. 9 points. Okay. Now what about the second one? Let's mean this is going to be 9.24 with the 0. Let's check. Do we have this point on the graph? It's supposed to be less than 9. Maybe we did something wrong because this is 5. This is negative. How many x-intercepts? 1, 2, 3, 4. We have 4 x-intercepts here. Well, because this is x squared. Okay. We have to take the square root. And here's the wrong thing. This is x squared here. We need to find x squared, x squared. So x squared. So taking the square root for this number is going to be 3. Now it's make more sense. So x is going to, and how many is going to be 2? So here is 1, 2, 3, 4, 5. Yeah, that's right. That's mean x is going to be, why I'm taking this the x squared, because you know it's power 4. That's mean from the quadratic formula you're going to find the square, which is the middle term. That's mean I'm going to get 2 roots from each side. So taking the square root for this number, going to be plus or minus 9.24, which is x is going to be plus or minus 3.4. That's mean almost a 3. From the second part is going to be 2, because it's going to be 10 minus 8.485. And this number is going to be 1 point. And also divided by 2, 3.5. What I'm saying, no, it's how we divide by 2. This one divided by 2, 0.75. So this means x is going to be the square root of 0.76. X is going to be plus or minus the square root of this number is going to be 0.87. Let's do it 0. That's mean again, I have from here the positive and I have negative, and from this side I have also positive, and I have the negative. Let's check these points. How many x-intercepts we have? We have 1, 2, 3, 4, 5. So I have 5 x-intercepts. If you look to these graphs, 5 x-intercepts. 1, let's check the first one. I have 2 here, so I'm not going to choose this one. I have 1, 2, 3, 4, and 5. I have 5 x-intercepts here. I have 1, 2. I have 1, 2 x-intercept. That means I can't choose this one, I can't choose this one, and I can't choose this one. So this one is the right one. If you go to the next step, we're going to find the y-intercept, which is let x equals 0. And I'm going to give you a few minutes just to write down everything. I'm going to try to do the steps here because I'm going to say step 2. Y-intercept. You're going to let x equals 0. So I'm going to go back to the original one. If you go back to the original one, if you put 0 here, 0 here, and 0 here, that means f of x is going to be 0. So f of 0 is going to be equal 1/5 0 to the power 5 minus 2 0 cubed plus 7/5 times 0, which is equal 0. That means the point is going to be 0, 0, which is exactly this one here in the middle. It's x-intercept and y-intercept on the same time. So this is the last step. N is 5, which is odd number. A is 1/5, which is greater than 0. So this side is up and this side is down, which is exactly like what we have on the graph. This side is up and this side is down. So that's it for this example. Next example is going to be example 13. Describe the left hand and the right hand of this graph. So this is, we're just going to say n equal 3, which is odd. So I'm going to say this is odd number. And A is negative 12. So if A is negative 12, which is less than 0, that means the left side is going down and the right side is going to be goes up, because this is the end behavior. That means the graph, this is up and the right is down. I'm just using the rule. So I'm going to choose the graph. It's not rise on the right. It's the graph is fall to the right and the graph is raised to the left. And choose this one. That's the only thing they're going to ask you here is about using the left and right side of the graph. The second 14 is going to be the same thing. Describe the left and right hand behavior. You see, it's behavior, or they call it end behavior of the graph. So we're going to do the same thing. N is equal to, be careful, it's written in descending order. That means from the highest exponent to the lowest one. This is the first step. And then this is even. A is a 3, which is greater than 0. That means positive number. So both sides of the behavior is going to be goes up. This side goes up and this side goes up. So we're going to choose it's raised from the right and it's raised from the left. Now I have to clean because, yes. Always before you write down the end behavior, make sure the function is written from the highest exponent to the lowest one. If you look to example 15, it's a tricky one because we're going to write down the function again. So it's 4 minus 5/2x minus 3x squared. So I'm going to say the function is in the standard form, it's negative 3x squared minus 5/2x plus 4. So I'm going to look to this one now. N is 2. A is negative 3. 2 is even. That means the end behavior from this side is down and from the left is down. So that we're going to choose the graph is false to the right and the graph is false to the left. Okay, so that's the difference with example 15. And I think the same thing with example 16. Because you have to look to the leading coefficient, which is the coefficient with the highest exponent. The same thing with example 16, it's f of x equal 5 minus x to the power 6. So we're going to do the same thing. I'm going to say f of x equal x negative x to the power 5 plus to the power 6 plus 5. So now n is 6, which is even, and a is -1, which is less than 0. So the graph also falling down from both sides. So it's false from the right and false to the left. Yeah, consider the following: f of x equal x squared minus 4. Before I start doing anything, I'm gonna factor this polynomial. So I'm gonna say f of x equal is difference between two squares. 4 is 2 times 2. So I'm gonna open two parentheses, one positive, one negative, 1x here, 1x here, and 1, 2 here, and 1, 2 here. That's it. This is the first step. Now let's check. How are we gonna find the zeros? The zeros, you're gonna just say equal, which is the same thing, the x-intercept. That's mean y equals 0. So I'm gonna say 0 equal x plus 2, x minus 2, because it's the same thing to find the x-intercept. So I'm gonna let y equals 0. That's mean 0 is going to be equal x plus 2, and 0 is going to be x minus 2. You're gonna minus 2 from both sides. So x is going to be equal -2. And here we're gonna add 2 to both sides. That means x is going to be equal to. So here is the zeros. That means the zeros, they already type here x. So again, do not type x again. You're just gonna say -2, comma 2. That means I'm gonna plug in here -2, comma 2. This is the first option. Now they're telling you describe whatever the multiplicity of each zero, of this 0 and this one. Then they're gonna ask you for the smallest value, which is -2. So -2, I got this -2 from this parentheses, which is from this one. Check the k here, the exponents here. The exponents here is 1. That means the k here is 1, so it's an odd multiplicity. Again, let's do it again, because this is really important. First of all, -2, which is the smallest value, that's what they're asking you here, the smallest x value, which is came from this parentheses, and this parentheses, which is this factor. This factor of the polynomial, the exponent here is 1, which is, if you remember, x minus k, sorry, minus, when I put here x minus the multiplicity, minus a. I type here x minus a to the k. K here, which is the multiplicity, if it's odd or even, which is the repeated zeros. So here is 1. That means it's an odd multiplicity. So I'm going to choose the smallest one as odd multiplicity. The large value, which is 2, 2 here, which is came from this parentheses, which is came from this factor. The same thing, the multiplicity here is 1. That's mean also it's an odd multiplicity. Determine the maximum possible of turning points. We need to find the turning points. The highest exponent is 2. So turn point equal n minus 1, which is 2 minus 1, which is equal 1. So this is the number of turning points. So I'm just going to type here 1. Now let's look to this graph. I click on this one by mistakes, so don't worry about this one. We have to analyze which one is going to be the right one. So here is the zeros, which is again is the same thing, the x-intercept. So we have 2 x-intercept, which is -2, 0, and 2, 0. So the zeros is the same thing, the x-intercept, because we let y equal 0. That means -2 and 2 is the x-intercept. So check here. This is not -2. This is not 2. So this is the wrong one. This is -2 and this is 2. So it could be this one. This is not -2. This is not 2. So this is wrong. This is -2 and this is 2. So maybe this one, maybe this one. I know you're going to use the calculator to find the right one, but let's check. What's the next step? I'm going to find the y-intercept. And I'm going to find the end behavior. So let's locate the end behavior first. The left side, n equal 2, which is even. A equal 1, which is greater than 0. That means both sides is going up. Both sides are going up. That means I can't choose this one because this side is up, this side is down. So this is the wrong, this is the right option. So the right option is going to be this one. That's clear, okay. So we already now know which one is the right option. Let's check if we found the y-intercept. And here is the second step. Y-intercept. This is x-intercept. You see the same step. We did the same step. Let f of x equals 0. And this is the y-intercept. We let x equals 0. I'm going to plug in 0 here. So f to the 0 equal 0 squared minus 4, which is equal -4. That means it's 0, -4. So this is the step 2, the y-intercept, which is right. Here is 0, -4. So this is the right option. I just want to check the y-intercept. So you see, we did exactly the same steps, finding the x-intercept, the y-intercept, the end behavior, and you can locate which one is going to be the right graph.